Imagine, for a moment, a silence so complete that even the idea of sound does not exist. A darkness so profound that it has no shape, no edges, no direction, because direction itself has not yet been born. A stillness so absolute that movement, distance, space, and even the concept of before and after mean nothing. This is not the universe in its infancy. This is the universe before the universe. A state so far removed from human experience that our language can only circle around it like a ship drifting near a shore it can never reach. There is no time, no past, no future, no flow, no ticking seconds, no unfolding moments. Just quiet. Not a peaceful quiet, not a hostile one, simply the absence of anything that could disturb or define it. A stillness without witness, a calm without air, a void without sighs. And in this impossible silence, there rests something mysterious, a kind of cosmic potential folded upon itself like a sleeping thought that has not yet turned into a dream. You might imagine it as a seed, not a seed floating in darkness because there is nowhere for it to float, not a seed waiting because waiting requires time, but a seed that is, silently containing everything that will ever come to be. Every star, every planet, every atom, every thought, every ocean, every mountain, every life that will someday open its eyes and wonder how all of this began. All of it is hidden inside that tiny, silent point of possibility. If you lean in gently with your imagination, you can sense that tension, a delicate balance between nothingness and everything. It is like the last deep breath before waking, a slow inhale before the first word of a story that will last billions of years. There are no colors yet, no light to reveal them, no shadow to oppose the light. There is not even emptiness, because emptiness implies space, and space has not yet been written into existence. It is the quiet before the first note of a cosmic symphony. A symphony that will someday fill the universe with galaxies, with the glow of distant suns, with swirling nebulae and the gentle pale blue of seas on distant planets. But for now, it waits. Or rather, it simply is. It is not calm because it chooses calmness. It is calm because calmness is the only possible state. This moment, if we can use such a word, is the closest we can ever get to imagining the true beginning. Even the greatest minds in physics struggle to describe it. They say there was no before, that time itself begins the instant the universe comes into being. And so, this is not the time before time, but rather the boundary between what cannot exist and what is about to exist. If you focus on this boundary, you might sense something faint, a kind of pressure, a growing tension, like the whisper forming far off in a dream. Nothing has happened yet, but something is beginning to push against the silence. A tiny imbalance in the absolute stillness, a stirring in the formless void, a tremor without sound, without movement, without space. It is the universe gathering itself. All the laws of physics, all the constants, all the building blocks of future stars and worlds, everything is collapsed into an unimaginably small, dense state. A state we call the singularity, though the word is only a placeholder. a human attempt to describe something no human was ever meant to witness. This silent singularity holds the blueprint for everything. The rules of gravity, the behavior of atoms, the speed of light, the curvature of space. Everything is compressed into a point so tiny that it defies imagination, and yet so potent that it will give birth to 13.8 billion years of cosmic evolution. As you sit with this image, the universe as a silent point of infinite density, let the stillness wash over you. Let the absence of time slow your breath. Let the weight of that cosmic quiet settle softly on your mind. Feel how vast the story is that waits inside that silence. How gently it rests before its first unfolding. How patient it seems, not because it must wait, but because time has not yet been invented to measure patience. And then something begins to change. Not a sound, not a movement, more like a shift in the underlying fabric of what could be. A soft ripple, like the faintest pulse traveling through a reality that has not yet opened its eyes. This pulse is the first hint that the silence will not last forever, that the calm will soon break into light, heat, and expansion, that the universe will soon awaken with unimaginable force. But for now, hold on to this moment, the last moment where nothing exists, the final breath before creation. A silence older than time, a calm deeper than space, and in the heart of that calm, the universe, still folded into a single silent point, prepares to begin its long journey from nothing into everything. Imagine that silent singularity again. That tiny point containing all the energy, all the potential, all the laws that will shape the universe. It rests in complete stillness, untouched, unmeasured, unseen. And then, in a moment without length, a moment with no before or after, the silence shatters. Not with a sound, because sound needs air. Not with light at first, because light needs space to travel. Instead, the universe begins with a sudden release of existence. A spark that does not shine outward, but creates the outward. A burst, not into space, but of space. This is the Big Bang. But do not imagine it as an explosion throwing debris into an empty room. There is no room. There is only the fabric of reality unfolding outward from an infinitesimal point, stretching and rushing into being. In the first fraction of a second, the universe expands faster than the speed of light, not by breaking any rule, but by writing the rules themselves. Space swells, energy spreads, the temperature rises to unimaginable levels, trillions upon trillions of degrees. A heat so intense that even the idea of matter cannot survive it. Everything is pure energy. This energy surges and churns like a storm made of light. It is wild, chaotic, roaring. Yet from this chaos, order will soon emerge. The universe is still incredibly small, but it is already growing, stretching like a newborn breath in every direction at once, formless but becoming, chaotic but destined to settle into patterns. Within the first 10 to the 31st seconds, a brief but astonishing event occurs: inflation. The universe suddenly expands by an incomprehensible scale. Regions billions of light years apart today were once so close they shared the same microscopic space.
This inflation smooths everything out, irons the wrinkles, sets the stage for cities of galaxies that will someday sparkle across the cosmos. And just as quickly as it began, inflation ends. The universe now begins to cool, not to comfort, but to possibility. As temperatures drop, energy condenses into the earliest forms of matter, tiny particles called quarks and gluons. They do not form atoms yet. They cannot. The universe is still far too hot, too dense, too wild. It is like watching raindrops attempt to form in boiling water. But the cooling continues. Second by second, the cosmos transforms. At around 1/1,000,000th of a second, the first protons and neutrons
begin to take shape, not as stable forms, but as flickers. They appear, disappear, and reappear, dancing in and out of existence in a sea of blinding radiation. The universe glows white-hot, not with light we could ever see, but with pure energy. A light so intense that it erases shadows before shadows can exist. Everything is expanding. Everything is cooling. Everything is changing at once. By the end of the first second, the universe is filled with a dense, blazing soup of particles, protons, neutrons, electrons, some matter, some antimatter, locked in an ancient struggle. Whenever matter meets antimatter, they annihilate each other, turning back into pure energy. It is a cosmic war, a dance of creation and destruction. And yet, somehow, matter wins, only by the smallest margin, an imbalance so tiny it defies logic. But without it, nothing would exist. No stars, no planets, no you, no me. Everything we will ever know is built from that small leftover fraction of matter that survived the annihilation. As minutes pass, the universe continues to cool. Still unimaginably hot, millions of degrees, but cool enough for something extraordinary to happen. The first atomic nuclei form. Hydrogen, helium, a trace of lithium. These are the universe's first ingredients, the simple notes from which all future complexity will be composed. But they are not atoms yet. Electrons cannot join them. The universe is still too energetic, too bright, too dense for them to calm down. The cosmos at this stage is like a brilliant begin to take shape. Not as stable forms, but as flickers. They appear, disappear, and reappear, dancing in and out of existence in a sea of blinding radiation. The universe glows white-hot, not with light we could ever see, but with pure energy, a light so intense that it erases shadows before shadows can exist. Everything is expanding, everything is cooling, everything is changing at once. By the end of the first second, the universe is filled with a dense, blazing soup of particles, protons, neutrons, electrons, some matter, some antimatter, locked in an ancient struggle. Whenever matter meets antimatter, they annihilate each other, turning back into pure energy. It is a cosmic war, a dance of creation and destruction. And yet somehow, matter wins, only by the smallest margin, an imbalance so tiny that it defies logic, but without it,
nothing would exist. No stars, no planets, no you, no me. Everything we will ever know is built from that small leftover fraction of matter that survived the annihilation. As minutes pass, the universe continues to cool. Still unimaginably hot, millions of degrees, but cool enough for something extraordinary to happen. The first atomic nuclei form. Hydrogen, helium, a trace of lithium. These are the universe's first ingredients, the simple notes from which all future complexity will be composed. But they are not atoms yet. Electrons cannot join them. The universe is still too energetic, too bright, too dense for them to calm down. The cosmos at this stage is like a brilliant fog, a fog so thick with light that no photon can travel freely. Everything is scattered, everything is glowing, everything is opaque. It will take hundreds of thousands of years before the first atoms form, before the fog clears, before the universe becomes transparent. But that is a story for another chapter. For now, the universe is only seconds old, a newborn wrapped in a blanket of radiation, expanding, cooling, and preparing itself for the long cosmic journey ahead. If you close your eyes and breathe slowly, you might picture this early universe not as an explosion, but as a rising tide of existence. A tide that begins at a single point and flows outward in every direction, filling the void with its first light. A tide that carries the seeds of galaxies, of stars, of life. A tide that transforms silence into song, stillness into motion, nothingness into everything. The Big Bang is not just a moment, it is the awakening. The instant the universe opens its eyes and begins to unfold its 13.8 billion year story. And as the newborn cosmos expands into the darkness, it carries with it a promise that from this chaos, beauty will emerge, that from this fire, future worlds will form, and that one day, after billions of years, a tiny creature on a small blue planet will look up at the night sky and wonder how it all began. Picture the universe now as a vast, expanding ocean of glowing energy. Not the gentle light of stars, because stars do not exist yet, but a dense, brilliant fog of radiation so thick that nothing can be seen through it. Everywhere particles collide, scatter, merge, and break apart again. The cosmos is still extremely young, only minutes old, but its future has already begun to take shape. What surrounds us is a kind of ancient storm, a storm of pure heat and light, stretching across the entire universe. There is no darkness, no direction, only an endless glow. Over time, the universe continues to expand, and as it expands, it cools, slowly, steadily, predictably. This cooling is not just a physical process. It's the universe preparing itself, preparing for structure, for form, for stability. And after roughly 3 minutes, something remarkable happens. The furious energy of the early universe softens just enough for the first stable atomic nuclei to form. Hydrogen, helium, a trace of lithium. These are not complete atoms yet. Electrons around them are still rushing wildly, unable to settle down. The universe is still too hot, too bright, too dense for them to calm down. But the ingredients of all future matter are now in place. Everything that will ever exist, every star, every planet, every mountain, every ocean, every living thing will be built from these simple nuclei. And now a long, quiet wait begins. The universe continues to stretch. Imagine a giant piece of cloth being pulled outward in all directions, growing thinner, cooler, and quieter with every passing moment. Minutes become hours. Hours become days. Days become years. Years become thousands of years. Tempers settle. Velocities slow. Chaos becomes order. The cosmic fog remains dense and glowing, but its brightness begins to soften, the way early morning light dims into a gentle dawn. 100,000 years pass. Still, the universe is not transparent. Photons, particles of light, cannot travel far before colliding with charged particles. Like cars in a tightly packed traffic jam, they bounce endlessly, unable to move freely. But the cooling continues. The expansion continues. The balance shifts. And then, around 380,000 years after the Big
Bang! Everything changes. Quietly, gently, beautifully. The temperature of the universe drops to a point where electrons can finally slow down enough to be captured by nuclei. For the first time in cosmic history, true atoms form. Hydrogen atoms, simple and elegant. Helium atoms, light and stable. As the electrons settle into their orbits, something extraordinary happens. Light is finally set free. The fog thins. The glow fades. Photons, after being trapped for hundreds of thousands of years, suddenly find the universe open and transparent. They travel in every direction, unimpeded. They spread across the cosmos, carrying with them a faint whisper of the early universe, a whisper that scientists today call the cosmic microwave background. It is the oldest light in existence. A message from the universe's childhood, still drifting through space after nearly 14 billion years. As the fog clears, the universe enters a period of profound darkness. Yes, darkness. Because even though the universe is transparent now, there are still no stars, no suns, no galaxies to illuminate the vastness. Only the soft afterglow of the early light, slowly fading as the universe expands. This period is known as the Cosmic Dark Ages, a time when matter exists but shines not at all. Hydrogen atoms float through space,
like tiny islands in an endless sea. Gravity begins to tug gently at them, pulling them into clumps, small at first, then larger still. These clumps will eventually collapse into stars, but that process takes time, millions of years, tens of millions. So for now, the universe rests in a tranquil darkness, a calm, silent interval that bridges the wild chaos of the Big Bang with the blazing brilliance that will come later. If you imagine yourself drifting through this young universe, a universe open, quiet and dark, you might feel a strange peace. No stars to dazzle you, no galaxies to overwhelm you, just a vast, soundless ocean of atoms slowly gathering together. Gravity is working patiently, gently, softly. Like hands shaping clay over millions of years, it draws matter together, tightening knots in the cosmic fabric. Tiny fluctuations, small ripples left over from the early universe, become the seeds of all future structure. Some regions pull in more matter, others remain sparse. Patterns begin to form. These invisible patterns will one day become galaxy clusters, superclusters, and the great cosmic web that stretches across the universe like a delicate lace of stars. But for now, everything is still quiet, still forming, still waiting. Slowly, hydrogen clouds grow denser. Atoms press closer together under gravity's pull. Temperatures rise again, but this time in local pockets rather than the entire cosmos. Deep within those pockets, at the center of the densest clouds, a new kind of light prepares to awaken. A light not born from the Big Bang, but from matter itself. The first stars are coming. But not yet, not in this chapter. For now, the universe floats in a peaceful, patient darkness, a darkness full of potential, of structure still forming, of stars not yet born. This is the calm before the cosmic dawn, the final night before the universe lights its first lanterns. A silent, dark ocean waiting for its first sparks of fire. And those sparks, the first stars, will change everything. For hundreds of millions of years, the universe has existed in near-perfect silence. No stars, no galaxies, no planets. Only the gentle drift of hydrogen and helium atoms slowly gathering under gravity's patient pull. The universe is transparent now, but its transparency reveals only darkness. A vast, quiet night stretching across unimaginable distances. But deep within that darkness, something delicate is happening, something that will change the destiny of the entire cosmos. Tiny whispers of gravity tug at loose clouds of hydrogen. The clouds swirl, merge, and fold over themselves. What was once a diffuse mist begins to clump into denser pockets. the first primordial clouds. They drift like ghosts in a black ocean. And slowly, quietly, they begin to collapse inward. As atoms fall toward one another, their motion quickens. Every collision adds a little heat. Every inward pull adds a little pressure. The collapse continues. The cloud grows tighter, denser, hotter. For millions of years, gravity squeezes the core of these clouds with relentless patience, as if kneading the dough of the cosmos. At first, the heat is mild. Then it grows. Millions of degrees, tens of millions. The pressure rises to unimaginable levels. And then, something happens that has never happened before. At the very center of these collapsing clouds, temperature and pressure become so extreme that hydrogen atoms can no longer remain separate. They fuse. Two become one. Mass becomes energy. Darkness becomes light. A new kind of fire is born, nuclear fusion, and with it, the first stars ignite. For the first time since the beginning of time itself, the universe shines. Tiny flames in an infinite night, the first lanterns of existence. This moment is called cosmic dawn, the awakening of the universe from its long, silent sleep. But these first stars are nothing like the stars we know today. They are giants, monsters of light and heat, hundreds of times more massive than our sun. Huge, violent, short-lived. Stars forged entirely from hydrogen and helium, with no heavier elements to cool them or ever slow them down. They burned hotter, brighter, and far more fiercely than the stars that will come later. Imagine standing beneath one, a blue-white colossus, raging with unimaginable intensity. Its surface boiling like a cosmic storm. If such a star were placed where our sun is today, its light would fry Earth instantly, its flames stretching millions of kilometers outward. Yet these ancient stars do not exist for long. Some survive only a few million years, the blink of an eye compared to the age of the universe. But during their brief lives, they reshape the cosmos. Their light clears away the remaining darkness. Their radiation tears apart hydrogen clouds, carving vast bubbles through space. Their heat begins to ionize the universe once more, turning cold atoms into charged particles. And deep in their cores, fusion forges the first heavy elements. Carbon, the backbone of life. Oxygen, the breath of future worlds. Nitrogen, silicon, iron. In these massive stellar furnaces, the universe is creating the raw materials for planets, oceans, and living beings. When these first stars reach the end of their short, furious lives, they die with spectacular violence. They collapse inward and then explode outward in the first supernovae. Explosions so bright that they outshine entire galaxies. They hurl newly forged elements into space, seeding the cosmos with the building blocks of everything that will ever be. The light from these first colossal stars began to carve pathways through the thick hydrogen fog. Slowly, region by region, photons broke free, ionizing the surrounding gas and allowing light to travel farther than ever before. This process was not instantaneous. It was gentle, patient, almost meditative in its unfolding, like a candle slowly melting the darkness of a vast frozen room. Clusters of stars formed in delicate pockets, creating the first proto-galaxies. Each pocket, a tiny island of fire, sent streams of energy into the surrounding cold void, stirring the primordial clouds. Gravity pulled these clouds together, creating denser knots that would, in time, collapse into the first real galaxies. The universe itself seemed to breathe. Inhale, exhale. Light stretched outward. Darkness retreated. Order emerged from chaos. Amidst this vast expanse, enormous stars lived fast and died young. When their cores could no longer sustain the immense pressure of nuclear fusion, they exploded as the universe's first supernova. Each explosion painted the darkness with brilliance, scattering heavier elements, carbon, oxygen, nitrogen, into the surrounding cosmos. These elements, forged in the hearts of the first stars, would become the building blocks of future planets, oceans, and even life itself. As time passed, the rate of star formation increased. Galaxies began to take shape, small at first, fragile, but steadily growing as they merged with neighboring clouds of gas and stars. The first spiral and elliptical shapes started to emerge, tracing delicate patterns across the expanding universe. Filaments of matter stretched like threads connecting these young galaxies, forming the earliest structures of the cosmic web. During this era, light became the language of the universe. Wherever it traveled, it changed the environment. Cold hydrogen gas was transformed. Once opaque regions became transparent. Darkness became illumination. The faint glow that had survived the cosmic microwave background now mingled with the radiance of stars, creating the first celestial panorama of color and shadow. As billions of years approached their mark, the universe slowly shifted from isolated pockets of fire to a more continuous illumination. The cosmic dawn gave way to the first true morning. In this era, galaxies clustered, voids expanded, and the seeds of larger cosmic structures were firmly planted. The universe, once an endless dark ocean, now rippled with islands of light, each one a story waiting to unfold. Every supernova, every burst of fusion, every gravitational dance contributed to this awakening. The first atoms of heavier elements joined the primordial hydrogen and helium, setting the stage for planets that would one day orbit new stars. The universe was no longer simply an expanse of gas and radiation. It was becoming a dynamic, evolving ecosystem where light and matter worked in concert to shape the very fabric of reality. In these moments, the cosmos whispered its first secrets. Though silent to the ear, the language of light, energy, and gravity told a story that would span billions of years. It was the story of beginnings, of possibilities, of everything that would one day emerge, from the smallest pebble to the largest galaxy, from the simplest molecule to the first living cells. And through all of this, the universe continued its slow, inexorable expansion. The dark sea between galaxies widened, yet the bonds of gravity held stars and gas clouds together, sculpting them into coherent forms. The first true cosmic structures emerged, not perfectly formed, not permanent, but enduring enough to survive the ages and to give rise to the endless diversity that would follow. Thus, the first light of the universe spread, filling the void with warmth and brilliance, signaling the end of the deepest darkness and the beginning of a universe that could see itself. As the first stars illuminated the universe, they were not solitary. They gathered, pulled together by gravity, into the earliest formations we now call galaxies. These were small at first, fragile clusters of stars and gas floating like islands in an immense dark ocean. Each galaxy was unique, shaped by the turbulence of its birth and the invisible currents of gravity that swirled through the cosmos. Each galaxy grows, merging with neighbors, forming larger and more complex shapes. Spirals begin to twirl, elliptical forms take shape, and irregular clusters display chaotic beauty. The first galaxies are chaotic yet beautiful. Their stars burn with intensity, often in short-lived flares, and their supernovae scatter heavy elements into the surrounding medium. These explosions seed the cosmic environment with carbon, oxygen, and nitrogen, the ingredients of future stars, planets, and life itself. Gravity acts as the sculptor of the cosmos. It gathers matter, shapes it, and pulls it into larger structures. Filaments stretch between galaxies like threads of light, forming a vast cosmic web. Dense nodes at the intersections of these filaments become the birthplaces of massive galaxy clusters. Dark matter, invisible yet dominant, forms the scaffolding upon which the visible universe assembles itself, guiding stars and gas into patterns that will endure for billions of years. Amidst this slow, grand choreography, galaxies collide and merge. Smaller galaxies are absorbed into larger ones, triggering waves of star formation that light up the surrounding space. Gas clouds compress under these interactions, igniting new stars in brilliant bursts of fusion. Each collision is both destructive and creative, a cosmic dance that reshapes the universe, turning chaos into harmony, randomness into structure. As billions of years pass, the first supermassive black holes begin to form at the hearts of some galaxies. They feed on surrounding matter, growing silently yet with immense influence, shaping the dynamics of their host galaxies. Jets of energy erupt from their cores, stirring gas and regulating the birth of new stars. These invisible giants are the silent guardians and architects of cosmic evolution, influencing the growth of galaxies across unimaginable distances. Through all this, light continues to travel across the universe. Photons emitted billions of years ago now reach us, carrying with them the story of these early galaxies. Each beam of light is a messenger from the past, revealing the formation of cosmic structures and the ongoing dance between gravity, matter, and energy. By observing this ancient light, we glimpse the universe as it was, long before planets, oceans, or life existed. The cosmos is no longer a featureless void. It is a complex tapestry woven from stars, gas, dark matter, and light. Islands of brilliance float in a dark sea, connected by threads of gravity and the remnants of primordial gas. Each galaxy tells a story of formation, evolution, and transformation, a story that will continue to unfold over billions of years. And yet, despite this complexity, there is still a profound calm. The universe grows, structures form, and light spreads, but the motions are governed by the slow, inexorable laws of physics. Patterns emerge naturally, not by intention, but by the silent, persistent interplay of energy, matter, and time. This is the era in which the universe finds its rhythm. The first stars light the darkness. The first galaxies gather their stars into coherent forms, and the cosmic web stretches across the vastness of space. Light and matter, order and chaos, creation and destruction, all are intertwined in a meditative, eternal dance that will continue for billions of years. And within this cosmic symphony, the stage is set for the next transformation, the formation of planets, the settling of stellar systems, and eventually the emergence of worlds capable of harboring life. The story of the universe continues, a slow, majestic unfolding, from the first sparks of stars to the intricate galactic structures that will someday give rise to countless possibilities. Within every young galaxy, stars do not form in isolation. They are born in clusters, tight-knit families of luminous bodies bound together by gravity. Imagine these stellar nurseries, dense clouds of gas collapsing under their own weight, igniting hundreds or thousands of stars at once. Each cluster is a miniature universe, a radiant island of energy scattered across the larger galaxy. In these clusters, stars of all sizes emerge. Massive blue giants burn intensely, their light reaching across the surrounding gas, while smaller, cooler stars settle into longer, quieter lives. The interplay of these stars determines the evolution of the cluster. Stellar winds push against surrounding gas, carving out cavities and triggering new waves of star formation. The death of a massive star in a supernova sends shock waves through the cluster, compressing gas clouds and seeding them with heavier elements. Clusters shape galaxies as much as galaxies shape clusters. Their collective gravity influences the motion of stars within the galaxy, guiding them along orbital paths and sculpting spiral arms. Over time, clusters drift apart, but their legacy persists. The stars that once shared the same cradle now populate the galaxy, carrying with them the chemical fingerprint of their birth. As galaxies grow, clusters migrate toward dense regions, forming globular clusters, ancient spherical assemblies of stars orbiting the galactic core. These clusters are like living fossils, containing some of the oldest stars in the universe. Observing them is like peering back billions of years into the past, witnessing the early processes that shaped galaxies. Meanwhile, the gas between stars is not idle. It swirls, compressed by gravitational forces and shaped by the energy of nearby stars. Streams of gas flow along galactic filaments, feeding regions of active star formation. In this cosmic dance, light and matter interact continuously. Stars illuminate the gas, while gas feeds the birth of new stars, creating a feedback loop that drives galactic evolution. Over millions of years, galaxies mature. Spiral arms take shape, their winding curves tracing the motion of stars and clusters. Elliptical galaxies smooth out into massive glowing ovals, their stars moving in coordinated harmony. Irregular galaxies retain chaotic, asymmetrical forms, evidence of past collisions and the ongoing influence of gravity. Yet all are interconnected in the cosmic web, each galaxy a point of light in the vast darkness, influenced by its neighbors and the invisible pull of dark matter. Through this process, the universe becomes a gallery of diverse structures, clusters within clusters, galaxies within filaments, the cosmic web stretching across unimaginable distances. Each element contributes to a rhythm, a pattern, a silent music of existence. The universe is no longer just a place where stars happen to shine. It is a symphony of energy, matter, and time, orchestrated by gravity and shaped by the life cycles of countless stars. And as the first galaxies settle into these forms, the ingredients for planets, solar systems, and eventually life are scattered across the cosmos. The heavier elements forged in early supernova, enriched and distributed by clusters, provide the raw materials for rocky worlds. Water, carbon, oxygen, everything necessary for life is sewn into the galaxy's fabric, waiting patiently for the right conditions to spark existence.
In this meditative expanse, the universe is both immense and intimate. Stars are born, live, and die within clusters. Clusters populate galaxies. Galaxies weave the cosmic web. Each level, from the smallest star to the grandest galactic filament, contributes to a continuum of creation, a slow and deliberate unfolding of the cosmos. And in this unfolding, one truth becomes clear. The universe is alive with rhythm and structure. From the chaotic first moments after the Big Bang, through the birth of stars and galaxies, to the intricate clustering of stellar families, there is a profound order emerging from the primordial chaos. The cosmic story continues, patient and majestic, guiding the universe toward ever greater complexity and the eventual emergence of worlds capable of harboring life. As galaxies continue to mature, their forms become increasingly complex. Spiral arms twist and curl, tracing the paths of billions of stars moving in concert under the influence of gravity. Elliptical galaxies glow with a smooth, uniform light, while irregular galaxies scatter their stars in asymmetric patterns, evidence of past collisions and cosmic turbulence. Each galaxy is a dynamic entity, alive with motion, energy, and transformation. Within these galaxies, star formation continues relentlessly. Dense molecular clouds collapse under gravity, igniting new generations of stars. These stellar nurseries are enriched with the products of previous generations: carbon, oxygen, nitrogen, and iron, elements forged in the hearts of massive stars and scattered by supernovae. This cosmic recycling is essential. Without it, planets like Earth could never exist. As stars are born, they often form in clusters, surrounded by swirling disks of gas and dust. Within these disks, gravity and angular momentum begin to sculpt the first planetary systems. Dust grains collide and stick together, forming larger bodies, which collide again, slowly building planets, moons, and asteroids. The universe is patient. These processes unfold over millions of years, gradually creating the diversity of worlds that will populate galaxies. Meanwhile, massive stars continue their brief, brilliant lives, shaping their surroundings with radiation and stellar winds. Their energy sweeps away residual gas and dust, influencing the formation of nearby stars and planetary systems. In some regions, this feedback triggers new waves of star formation,
In others, it halts growth, leaving pockets of emptiness. This delicate balance between creation and destruction governs the evolution of galaxies and the emergence of complex structures within them. The interplay of gravity, light, and matter sculpts the architecture of galaxies. Stars orbit galactic centers, clusters drift and dissolve, gas flows along filaments, and black holes silently influence their surroundings. Each process contributes to the larger cosmic pattern, a web of relationships and forces that spans billions of light years. Through it all, the universe gradually becomes more structured, more interconnected, more capable of supporting the eventual emergence of life. Heavy elements, forged in earlier generations of stars, are scattered throughout the galaxy, seeding molecular clouds with the ingredients for planets. Carbon, the foundation of organic chemistry, mingles with oxygen to form water. Iron and silicon become part of rocky cores. In this way, the building blocks of terrestrial worlds are distributed across the cosmos, waiting for the right conditions to coalesce into planets capable of supporting complex chemistry. By now, galaxies are no longer simple islands of stars. They are ecosystems of matter and energy, each with its own history, dynamics, and potential. Star formation, planetary system development, and chemical enrichment occur simultaneously, weaving an intricate tapestry of cosmic evolution. Every collision, every supernova, every gravitational pull contributes to the ongoing story of the universe, shaping the environments where planets and life might one day arise. Through this meditative expanse, we see the universe becoming increasingly familiar. Stars shine, galaxies form, and planetary systems begin to take shape. The ingredients for life, carbon, oxygen, nitrogen, water, exist in abundance, distributed across space, waiting for the right combination of circumstances to spark existence. The universe is patient, unfolding over billions of years, each stage building upon the last, gradually preparing the stage for worlds like our own. And so, in the quiet and vast reaches of space, the seeds of planetary systems are sown. From the remnants of dead stars, from swirling clouds of gas and dust, new worlds will emerge. Some may remain barren, silent, and cold. Others may harbor oceans, atmospheres, and life. This is the promise of the cosmos, written into its very structure, a slow and deliberate unfolding that stretches from the earliest galaxies to the first habitable planets. Amidst the vast galactic canvas, in a quiet corner of the Milky Way, a small cloud of dust and gas began to coalesce. Gravity pulled the particles together, forming a young glowing star we now call the Sun. Around it, the leftover gas and dust swirled in a vast protoplanetary disk, spinning and colliding, slowly giving shape to new worlds. Within this disk, particles collided, sticking together to form larger and larger bodies. Tiny rocks became pebbles, pebbles became boulders, boulders collided, merging into planetesimals. These early objects were chaotic, constantly reshaping, growing, and sometimes shattering in violent collisions. The process was slow, patient, and precise, governed entirely by the immutable laws of physics. One of these growing bodies, a young planet forming at just the right distance from the Sun, accumulated enough mass to pull itself into a roughly spherical shape. This planet, forged from stardust, would one day become Earth. It was initially a molten, fiery world, constantly bombarded by debris from the protoplanetary disk. Giant impacts reshaped its surface, sending shock waves through its interior and expelling material into space. Gradually, the planet cooled. Its surface solidified, forming the first fragile crust. Volcanoes erupted, releasing gases that would become the early atmosphere. Hydrogen, water vapor, carbon dioxide, nitrogen. These gases began to fill the sky, wrapping the young Earth in a shroud of potential. Heavy bombardment continued, but slowly, order began to emerge from chaos. Water, delivered by icy comets and from degassing within the planet itself, began to accumulate on the surface. Streams formed, pooling into larger bodies. Oceans took shape, vast and silent, reflecting the faint light of a young sun. The first rain fell, carving channels into the nascent crust, creating rivers and lakes that would one day sustain life. The planet, born of stardust and fire, now held liquid water, a crucial ingredient for the future. The moon formed shortly afterward, likely from a colossal impact with a Mars-sized body. Debris from this collision coalesced into a satellite, orbiting the young Earth and stabilizing its rotation. This celestial companion would influence tides, climate, and the rhythm of life for billions of years to come. As the surface cooled and oceans formed, the atmosphere became more stable. Clouds drifted across the sky. Gentle winds blew over the oceans. Lightning sparked in the storms, mixing gases and energy in ways that would set the stage for chemistry. The stage for life, though invisible at first, was quietly being prepared. And in this meditative silence, the universe had come full circle. Elements forged in the hearts of ancient stars now combined to form planets. Galaxies had grown, stars had lived and died, and the materials of cosmic alchemy were gathered on this small blue world. Earth was born, not in a single instant, but through countless interactions, collisions, and processes unfolding over millions of years. From this point onward, the story of the universe becomes intimately connected with the story of Earth. Oceans reflect the sky. Atmospheres trap heat. The solid crust provides a stable surface. Every atom on this planet, every drop of water, every grain of rock carries the legacy of the stars, of the galaxies, of the vast and patient cosmos. In the silence of early Earth, there is a profound sense of anticipation. The planet is young, fragile, and full of potential. Life has not yet emerged, but the stage is perfectly set. Water flows, volcanoes breathe. The first dawns paint the sky with light, and the universe, in its quiet majesty, watches as a new chapter prepares to begin. On the young Earth, oceans stretched endlessly, reflecting the faint light of a warming sun. Volcanic plumes rose into the sky, releasing gases and minerals into the atmosphere. The surface seemed harsh and uninviting, yet within the depths of the oceans, the universe was quietly preparing the first spark of life. Life did not appear suddenly. It emerged from chemistry, a slow, patient process where molecules collided, bonded, and formed increasingly complex chains. Carbon, hydrogen, oxygen, nitrogen, elements forged in the hearts of ancient stars interacted in the watery pools. Energy from lightning, heat from hydrothermal vents, and ultraviolet light from the young sun catalyzed these reactions. Gradually, molecules capable of storing information and catalyzing reactions began to form, setting the stage for the first living cells. These primordial organisms were simple, microscopic, but resilient. They thrived in the oceans, drawing energy from chemical gradients, sunlight, and nutrients dissolved in the water. For millions of years they existed quietly, shaping the chemistry of the oceans and the atmosphere around them. Cyanobacteria, for example, began to harness sunlight, performing photosynthesis and slowly releasing oxygen into the surrounding water. The atmosphere itself was transforming. Initially dominated by carbon dioxide, methane, and nitrogen, it gradually gained oxygen. This oxygenation was slow, imperceptible, yet irreversible. Tiny biological processes began to alter the planet on a global scale. Oceans absorbed oxygen. Rocks trapped it. Life was rewriting the rules of the environment, one molecule at a time. Over eons, these processes created conditions suitable for more complex life. Oxygen levels increased, ozone formed, and the first protective layers in the atmosphere emerged. Earth became a planet capable of sustaining diversity, a dynamic system where chemistry, biology, and physics intertwined. The stage was set for the explosion of life, for the emergence of multicellular organisms, for the eventual arrival of plants, animals, and, billions of years later, humanity.
Through all this, the universe continued its quiet expansion. Galaxies spun in their cosmic dance, stars were born and died, and planets formed around distant suns. Yet on this small blue planet, the cosmos had left a special gift: life. From the ashes of ancient supernovae, from the swirling dust of galaxies, Earth became a vessel for creation, a sanctuary for molecules that learned to replicate, adapt, and evolve. And so, as we gaze at the stars, we can see the story reflected back at us. Every atom in our bodies, every breath of oxygen, every drop of water carries the legacy of 13.8 billion years of cosmic history. From the Big Bang to the first stars, from galaxies to planetary systems, from oceans to the first living cells, the universe has been unfolding, patiently, gracefully, silently, preparing the stage for life to emerge. In the stillness of this story, there is a meditation on time, on patience, and the profound interconnectedness of everything. The universe, in its majestic expanse, is both ancient and alive, and we, as witnesses to its unfolding, are part of a tale that began in darkness and silence and continues to this very moment, echoing across the cosmos. After billions of years of quiet chemical evolution and microscopic life, Earth began to hum with subtle energy.
Microbes thrived in oceans, lakes, and tidal pools, performing unseen work, shaping the planet's chemistry and setting the stage for complexity. Life was no longer a mere possibility. It was a persistent force, steadily influencing its environment. Photosynthetic organisms continued to produce oxygen, gradually saturating the oceans and the atmosphere. This slow oxygenation, known as the Great Oxygenation Event, was a turning point. It altered chemical reactions, enabled the formation of the ozone layer, and created a shield against harmful solar radiation. Life could now expand into new niches, from the deep seas to shallow waters, and eventually onto land. Meanwhile, evolutionary experiments unfolded at the microscopic level. Single-celled organisms diversified, adapting to temperature, salinity, and nutrient availability. Some formed colonies, cooperating and communicating, laying the foundation for multicellular structures. Symbiotic relationships emerged, where one organism relied on another for survival, and together they achieved complexity that a single cell could never achieve alone. These interactions were subtle, almost imperceptible, but their impact was profound. Each mutation, each cellular innovation set the stage for future organisms. Nature's slow hand guided the emergence of diversity. Tiny organisms that survived harsh conditions left descendants that would carry forward the innovations of survival, metabolism, and reproduction. On the planetary scale, Earth itself was being shaped by life. Microbial mats stabilized sediments. Photosynthetic bacteria influenced the atmosphere. The interplay between biological and geological processes created a feedback loop. Life changed the environment, and the environment shaped life in turn. Mountains rose, oceans circulated, and climates shifted, all under the silent influence of microbial and chemical activity. Time stretched forward, billions of years passing like a gentle river. Life remained largely invisible to the naked eye, yet it was everywhere, persistent, patient, quietly preparing the stage for the dramatic transformations yet to come. Evolution was not a race. It was a slow, meditative unfolding, a cosmic choreography of adaptation and survival. Eventually, multicellular life appeared. The first simple organisms began to differentiate, to specialize. Cells that had once been identical discovered the power of cooperation, forming the earliest tissues and rudimentary structures. It was the beginning of an upward journey from simplicity to complexity, a process that would take eons and unfold in the silent theater of Earth. In this meditative expanse, one can sense the patient rhythm of the universe. Life emerges not in sudden bursts, but in long, quiet stretches of time. Each organism, each cellular innovation is a note in the symphony of evolution, building toward forms that will one day roam the land, swim the oceans, and even gaze at the stars.
Imagine drifting through these primordial seas. The water teems with movement. Tiny creatures dart through coral-like structures.
Others crawl along the seabed, and predators chase their prey in a silent, intricate ballet. Every organism carries adaptations honed over eons: limbs, shells, sensory organs, mechanical solutions to the challenges of survival. Evolution had shifted into overdrive, creating not just life, but a dizzying array of strategies and forms. Environmental factors played their role. Oxygen levels in the oceans had reached a threshold sufficient to support more energy-intensive metabolisms. Light penetrated deeper waters, allowing vision to evolve. Predation emerged as a new force, driving innovation and competition. These pressures combined to create a feedback loop of rapid diversification. As species adapted, new niches opened, which prompted further adaptations, and the cycle continued. In this era, ecosystems became interwoven. Food webs grew complex, with producers, consumers, and decomposers interacting in dynamic ways. The interplay between organism and environment intensified. Life was no longer a passive occupant of Earth's oceans. It was a powerful shaper of the planet's chemistry and landscapes. Coral reefs, though primitive, formed structures that would become havens for countless creatures. Sediment stirred by burrowing animals reshaped ocean floors, altering currents and nutrient flows. The Cambrian explosion represents not just an increase in the number of species, but an exponential rise in the variety of body plans. Limbs, exoskeletons, eyes, and sensory organs evolved in multiple lineages, setting the blueprint for life that would follow. Predators honed hunting strategies, while prey developed defensive mechanisms. Adaptation became rapid, deliberate, a visible expression of evolution's creative power. This period reminds us that life is both resilient and inventive. It transforms, adapts, and diversifies, sometimes slowly, sometimes in sudden bursts. The Cambrian explosion was a testament to the universe's ability to nurture complexity. From the first sparks of microbial life to intricate multicellular organisms capable of movement, sensation, and interaction. And in the meditative expanse of time, these oceans, alive with motion and color, hold the memory of Earth's earliest experiments in complexity. They are a stage where life learns to innovate, to compete, and to thrive, a prelude to the magnificent diversity that will later populate land, sea, and sky.
The story of the Cambrian explosion is the story of acceleration, the first great leap from simplicity to diversity. It is a meditation on possibility, adaptation, and the patient unfolding of life's potential, echoing the silent, grand orchestration of the cosmos itself. After millions of years of flourishing in the oceans, life began a bold new experiment. It moved onto land. The first pioneers were plants, simple yet determined. Mosses, liverworts, and other primitive flora crept across moist soils and riverbanks, capturing sunlight and transforming carbon dioxide into energy. These early colonizers were the architects of a new world, quietly preparing the land for the creatures that would follow. Imagine the landscape: rocky shores, gentle streams, and wetlands slowly becoming green with the first photosynthetic life. These plants anchored the soil, preventing erosion, while releasing oxygen that began to accumulate in the atmosphere. They were silent engineers, reshaping the terrestrial environment with patient persistence.
Their presence allowed soils to form, habitats to stabilize, and eventually ecosystems to flourish. Soon after, animals joined this terrestrial adventure. Arthropods, small yet resilient, crawled onto land, feeding on microbes and plant matter. They carried the legacy of the oceans with them, breathing through specialized structures, adapting to gravity, and surviving the challenges of a new medium. These creatures were the first architects of land-based food webs, their interactions laying the foundation for more complex ecosystems. The process was gradual and measured. Life did not leap to land suddenly. It adapted, step by step. Moisture-loving organisms ventured out of shallow waters, gradually developing ways to conserve water, resist desiccation, and navigate solid surfaces. Evolution, in its patient rhythm, engineered solutions for movement, reproduction, and survival in a world without the buoyancy of water. Over millions of years, plants grew taller, creating forests that sheltered insects and provided shade and nutrients to smaller organisms. Fungi joined the terrestrial stage, forming symbiotic relationships with roots, enhancing nutrient absorption and accelerating the transformation of soil. Life on land became an interconnected network. Plants, fungi, and animals co-evolved, each influencing the success and structure of the others. Predation and competition followed. Arthropods developed strategies for hunting and defense. Some animals adapted to climbing, burrowing, or gliding. The first terrestrial food chains emerged, intricate and delicate, governed by energy flow and survival instincts. Every movement, every adaptation, every interaction contributed to the shaping of Earth's first true ecosystems. Through all this, the planet's atmosphere continued to evolve. Oxygen levels stabilized, supporting more complex metabolisms. The ozone layer thickened, protecting life from harmful ultraviolet radiation. The land, once hostile and barren, became habitable, a stage for innovation, diversity, and experimentation. This era represents a monumental leap, the first bridging of two worlds, the oceans and the land. Life had not only survived, but had begun to thrive in a new environment. The patient rhythm of evolution orchestrated an intricate dance where adaptation and persistence allowed life to claim the continents. And so, the Earth's surface, once silent and empty, now buzzed with activity. The first forests whispered in the wind. Tiny arthropods scuttled along the undergrowth. Fungi spread silently beneath the soil. Life was no longer confined to water. It had expanded, diversified, and begun to write the next chapters of its story. Chapters of complexity, resilience, and the ongoing triumph of creation across the surface of the planet. Once life had established a foothold on land, a new chapter began, the emergence of vertebrates that could navigate both water and earth. These were the first amphibians, creatures that straddled two worlds, inheriting traits from their aquatic ancestors while adapting to terrestrial life. Limbs, lungs, and specialized sensory organs allowed them to move across land, hunt, and survive outside the protective buoyancy of water. Imagine a misty Devonian landscape, shallow rivers flowing through dense primitive forests. Along their banks, early amphibians crawled, skimming between pools, basking in the sunlight, occasionally returning to water to reproduce or avoid desiccation. Their movements were deliberate, cautious, yet increasingly confident as evolution fine-tuned their physiology for a dual existence. These pioneers were small compared to the massive plants around them, yet they played a pivotal role in shaping ecosystems. They were both predator and prey, feeding on insects and smaller organisms while avoiding larger aquatic predators. Their life cycles, dependent on both water and land, linked ecosystems in complex ways, transferring energy and nutrients across habitats.
Over millions of years, amphibians diversified. Some evolved elongated bodies for burrowing. Others developed powerful limbs for climbing or swimming. Evolution experimented relentlessly, trying countless variations, gradually shaping lineages that would give rise to reptiles, birds, and mammals. Each adaptation, stronger skeletons, more efficient lungs, improved sensory perception, was a stepping stone toward mastery of the terrestrial realm. The land itself was changing. Plants grew taller, forming dense forests that created microhabitats. Fallen leaves and decaying wood enriched the soil, providing food and shelter for countless organisms. Rivers and ponds became bustling arenas of life, where amphibians, insects, and fish interacted in a delicate balance. The interplay between life and environment was becoming increasingly sophisticated, a complex web of energy and adaptation. Predation became a key driver of evolution. Amphibians had to develop speed, camouflage, and cunning to survive. In response, prey evolved defenses, shells, toxins, and escape behaviors. This co-evolution created a dynamic landscape where every species influenced the survival and evolution of others. Life was no longer a static existence, but a constant, evolving dialogue between organisms and their world. The rise of amphibians marked a turning point in Earth's story. Life was no longer bound to water alone. Land was being claimed and transformed. Ecosystems were expanding in complexity, and the foundations for future terrestrial animals were being laid. The patience of evolution, measured in millions of years, was now beginning to give dividends as life adapted to new challenges and opportunities in remarkable ways. And so, the Devonian forests and rivers became the stage for the first great terrestrial adventures. Amphibians, bridging water and land, carried the legacy of aquatic life into the New World. Their cautious steps, repeated over millions of years, set the rhythm for the rise of all land-dwelling vertebrates, shaping a planet increasingly alive with movement, interaction, and the silent orchestration of evolution's patient hand. Following the amphibians' cautious conquest of land, evolution took a decisive step: the emergence of the first reptiles. These creatures carried the lessons of their amphibian ancestors, but evolved a key innovation that would change life on Earth forever: the amniotic egg. No longer bound to water for reproduction, reptiles could colonize drier environments, laying eggs that contained all the nutrients necessary for a developing embryo.
Picture the landscapes of the late Carboniferous and early Permian periods, vast forests, swamps, and floodplains teeming with life. Amphibians thrived near water, but reptiles began to explore the drier expanses, their leathery-skinned bodies conserving moisture, their limbs strong enough to traverse varied terrain. These pioneers were small at first, cautious in movement, but they represented the first truly independent terrestrial vertebrates. Reptiles diversified rapidly. Some became agile predators, hunting insects and smaller amphibians. Others adapted to herbivory, grazing on ferns and primitive plants. Evolution experimented with size, shape, and physiology. Skeletons became stronger, jaws more efficient, and sensory organs increasingly sophisticated. The stage was set for life to expand across every terrestrial niche. The ecosystems themselves responded. Dense forests and evolving plant life provided shelter, food, and competition. Insects, amphibians, and reptiles interacted in a delicate web, each species shaping the evolution of the others. Predation and survival pressures intensified, leading to an accelerated pace of adaptation. Life was no longer static, it was dynamic, complex, and ever-changing. Meanwhile, Earth's climate and geology influenced evolutionary trajectories. Rising mountains, shifting rivers, and the gradual drying of certain regions created new habitats. Reptiles thrived where amphibians could not, exploiting environments previously inaccessible. In these dry, sunlit expanses, evolution continued its slow, deliberate work, crafting lineages that would eventually give rise to dinosaurs, birds, and mammals. The rise of reptiles also brought new behavioral patterns. Some sought shelter in burrows, others basked in sunlight to regulate body temperature. Social interactions, competition for mates, and territorial behaviors began to emerge, subtle yet profound forces guiding natural selection. Life had entered a new era where both physiology and behavior intertwined to shape survival and success. This period represents the unfolding of terrestrial complexity. Life was no longer a mere passenger of the planet. It was an active sculptor, transforming landscapes, influencing climates, and diversifying at every level. Reptiles, small but pivotal, were the architects of this new order, carrying evolution forward and bridging the gap between early amphibians and the more spectacular terrestrial vertebrates yet to come. And so, in the quiet rhythm of prehistoric Earth, the first reptiles moved across forests and plains, marking a decisive expansion of life into the terrestrial world. Their steps, cautious yet deliberate, opened new paths for adaptation, setting the stage for millions of years of diversification and the eventual rise of some of Earth's most iconic creatures. As life flourished across Earth's continents, the planet approached one of its most dramatic turning points. The Permian period, with its vast forests, thriving amphibians, and early reptiles, was drawing to a close, and with it came a cataclysm that would reshape the course of life: the Permian-Triassic extinction event.
This mass extinction, the most severe in Earth's history, erased nearly 90% of marine species and more than 70% of terrestrial species.
Volcanoes erupted across vast regions, releasing enormous quantities of carbon dioxide and sulfur dioxide. Oceans became acidic, oxygen levels plummeted, and the delicate balance of ecosystems collapsed. Landscapes that once teemed with life fell silent, shrouded in ash and toxic gases. Imagine standing on the desolate shores of a devastated Permian world. The rivers are choked with sediment, forests lie scorched and broken. The cries and movements of countless creatures have vanished. Yet even in this desolation, the planet is quietly preparing for renewal. Mass extinctions, while devastating, are not the end. They are transformative, clearing space for life to reimagine itself.
The aftermath was a world of survivors. The species that endured were often small, resilient, and adaptable. Amphibians, some reptiles, and early synapsids persisted, finding refuge in pockets of habitable land and water. These survivors carried the legacy of pre-extinction life, but their descendants would inherit a world almost unrecognizable, a blank canvas ready for evolutionary experimentation. Over millions of years, ecosystems began to recover. Forests re-emerged, rivers flowed freely, and the seas slowly refilled with life, albeit in forms markedly different from their predecessors. Life became more experimental, more diverse, as evolution responded to the new challenges and opportunities of a transformed planet. The Permian extinction teaches us a profound lesson. Destruction and creation are intertwined. Catastrophes, though violent and abrupt, open the door to innovation. The survivors, shaped by extreme selection pressures, set the stage for the rise of the dinosaurs, the evolution of birds, and the eventual emergence of mammals. Life, in its patient persistence, continues to adapt, diversify, and thrive, even in the wake of unimaginable loss. In this meditative reflection, one can sense the quiet resilience of the biosphere. Time stretches across millions of years, and the memory of extinction lingers in the DNA of survivors. From the ruins of the Permian world, life slowly, silently rebuilds, guided by the same forces that have shaped the cosmos since the Big Bang: chemistry, physics, and the inexorable pressure of adaptation. And so, even amidst cataclysm, the story of Earth continues. The planet is scarred, yet alive. Life persists, evolves, and finds new paths. The Permian extinction was both an ending and a beginning, a stark reminder of the fragility and resilience of life, and a meditation on the patient unfolding of nature's grand narrative. After the devastation of the Permian extinction, Earth entered the Triassic period, a time of renewal, experimentation, and cautious recovery. The planet, scarred but resilient, slowly became hospitable once more. Forests regrew, rivers flowed freely, and oceans teemed with emerging life, albeit in forms markedly different from their predecessors.
It was during this era that one of the most iconic lineages of terrestrial life began to rise: the dinosaurs.
From small, nimble reptiles that cautiously explored new niches, dinosaurs gradually diversified, adapting to a world still recovering from catastrophe. Their evolution was patient and deliberate, a gradual process of experimentation and selection that would, over millions of years, produce astonishing diversity. Visualize the early Triassic landscapes, open floodplains dotted with primitive ferns and conifers, shallow streams inhabited by amphibians and small reptiles. In these environments, the first dinosaurs hunted insects, small vertebrates, and scavenged when necessary. Their limbs became more upright, their posture more efficient, allowing faster movement and greater endurance. Senses sharpened, providing advantages in navigation, hunting, and survival. Triassic life was not yet dominated by dinosaurs, but the groundwork was being laid. Synapsids, amphibians, and early reptiles still held significant niches. Predation, competition, and adaptation drove an intricate dance of survival. Yet the dinosaurs, through subtle physiological and behavioral innovations, were quietly positioning themselves as the future rulers of terrestrial ecosystems. Meanwhile, the planet itself continued to shape evolution. Shifting continents, fluctuating climates, and volcanic activity created new challenges. Water availability fluctuated, seasonal changes became more pronounced, and ecological pressures tested every species. Life responded, diversity increased, specialization occurred, and ecosystems slowly gained complexity. The Triassic period reminds us that evolutionary success is rarely sudden. It is cumulative, built on the lessons of survival, adaptation, and environmental interaction. Dinosaurs, emerging from small, resilient ancestors, exemplified the patient and persistent rhythm of life, slowly mastering movement, balance, and hunting strategies that would define their dominance in the coming millions of years. As the Triassic unfolded, the interplay between biology and environment grew ever more intricate. Plant life provided shelter and food. Predators refined hunting techniques, and prey species evolved defenses. Each interaction, each adaptation was a note in the symphony of life, echoing across rivers, plains, and forests as evolution continued its patient, meditative work. And so, the dawn of dinosaurs was not a sudden eruption, but a slow, deliberate unfolding. From the ruins of Permian catastrophe, life rose again, experimenting, diversifying, and building foundations for one of Earth's most remarkable eras. The Triassic world, though still fragile and recovering, had begun to host the first steps of creatures that would dominate continents for millions of years, a testament to life's resilience and the silent orchestration of evolution across deep time. As Earth emerged fully from the shadows of the Triassic, the Jurassic period unfolded like a vast green tapestry. Forests of conifers, cycads, and ferns stretched endlessly across continents. Rivers meandered through fertile plains, while towering trees provided shelter and sustenance for a burgeoning diversity of life. This era was marked by a spectacular evolutionary crescendo, the rise of the giant dinosaurs. In these ancient landscapes, the largest creatures ever to walk the earth began to appear. Sauropods, with necks reaching skyward, browsed the treetops, consuming vast quantities of foliage. Their enormous bodies were supported by pillar-like legs, and their slow, deliberate movements reshaped the environment around them. Forests adapted to their presence. Plants evolved defenses, while their constant grazing influenced patterns of vegetation and soil distribution. Predator dinosaurs evolved in tandem. Theropods, agile and intelligent, prowled the forests and plains. Their keen senses, sharp teeth, and strong limbs made them formidable hunters. Each predator-prey interaction was a delicate balance, a silent dance choreographed over millions of years, reflecting the patient pressures of evolution. The roar of life was growing louder, more intricate, more complex. Marine ecosystems flourished alongside terrestrial ones. Oceans teemed with ammonites, ichthyosaurs, and plesiosaurs. Coral reefs expanded, providing habitats for countless species. Life in the water mirrored the dynamism on land, hunting, fleeing, adapting, surviving. The Jurassic period was a symphony of life in every habitat, each species contributing to a network of interaction and interdependence. Plants, too, evolved alongside animals. Conifers dominated, creating vast forests with towering canopies. Early flowering plants began to appear, though still rare, hinting at the botanical revolutions to come. Ecosystems became layered, with life occupying niches both on the ground and above, in the undergrowth and the high canopy, creating complex, interdependent systems. This period demonstrates the patient rhythm of natural selection. Gigantic herbivores and formidable predators were not sudden inventions, but the result of continuous adaptation, feedback loops, and environmental pressures stretching across millions of years. Evolution experimented, refined, and repeated, producing spectacular forms perfectly suited to their ecological niches.
The Jurassic was also a time of continental drift. Pangaea continued to fragment, shaping climates, isolating populations, and creating new evolutionary pressures. Life responded with diversification, occupying new lands and exploring novel strategies for survival. Every step of a dinosaur, every flutter of a leaf, every ripple in a river was part of the silent orchestration of life, unfolding with patience and purpose. And so, the Jurassic world was one of majesty and scale. The largest creatures yet to roam the earth walked beneath towering forests. Predators hunted with precision, and ecosystems thrived in complexity and balance. Life, having recovered from earlier catastrophes, now dominated both land and sea, its grand narrative echoing the patient, meditative rhythm of evolution across deep time. Following the grandeur of the Jurassic, Earth entered the Cretaceous period, a time of astonishing diversification and evolutionary innovation. Forests became more complex, rivers more dynamic, and the land was alive with creatures of every imaginable shape and size. The Cretaceous marks the age when dinosaurs reached the peak of their diversity, and flowering plants began to transform the landscapes forever. Picture vast plains dotted with towering conifers, interspersed with the first flowering plants, delicate blooms that would one day dominate Earth's vegetation.
These plants brought new colors, scents, and strategies for survival. Insects and herbivorous dinosaurs discovered new food sources. Pollination networks emerged, and the entire terrestrial ecosystem became more interconnected and intricate than ever before. Dinosaurs evolved into extraordinary forms during this period. Massive sauropods still roamed the plains, their immense bodies consuming huge quantities of plant matter. Predatory theropods, ferocious, agile, and cunning, hunted with unparalleled efficiency. Some species developed feathers, a precursor to the evolution of birds, while others exhibited elaborate crests, horns, and defensive structures. Adaptation was at its zenith. Survival required ingenuity, speed, and sometimes sheer size. Marine life thrived in parallel. Oceans teemed with mosasaurs, plesiosaurs, and schools of fish. Coral reefs expanded further, supporting diverse communities of invertebrates and vertebrates alike. Predators and prey co-evolved, creating dynamic food webs that mirrored the complexity found on land. Life in every environment was vibrant, diverse, and interconnected. The Cretaceous atmosphere was also evolving. Increased levels of oxygen and carbon dioxide, combined with shifting continents and climate zones, created varied habitats. Deserts, forests, wetlands, and coastal areas each hosted unique communities. Evolution responded to these challenges, producing remarkable specialization and ecological diversity. Flowering plants, or angiosperms, were revolutionary. Their ability to reproduce quickly and attract pollinators reshaped ecosystems. They provided new food sources, habitats, and opportunities for herbivores. Insects and other organisms adapted to exploit these new resources, illustrating the profound interplay between flora and fauna. Evolution was a dialogue, a slow, meditative conversation between life forms and their environment. Yet the Cretaceous period was not eternal. Beneath its vibrant surface, forces were stirring that would bring this extraordinary era to a sudden close. Volcanic activity, climate fluctuations, and eventually an asteroid impact loomed in the future, preparing to reshape life once more. But for millions of years, the Cretaceous stood as a pinnacle of diversity, adaptation, and the intricate dance of life at its fullest expression. As we imagine these landscapes, forests rich with color, plains alive with massive herbivores, skies patrolled by agile predators, we sense the harmony and tension that governed every interaction. Life had become extraordinarily complex, yet it remained fragile, dependent on the balance of environment, evolution, and adaptation. The Cretaceous world exemplifies the peak of Earth's terrestrial creativity, a moment in time when life achieved both splendor and sophistication. And so, in the grand story of Earth, the Cretaceous period represents both culmination and preparation, the climax of dinosaur diversity, the rise of flowering plants, and the intricate webs of life that would set the stage for future chapters, echoing the patient, meditative rhythms of evolution across billions of years. After millions of years of extraordinary diversification, the Cretaceous period approached its dramatic conclusion. Earth had become a vibrant mosaic of life. Towering dinosaurs roamed plains and forests. Flowering plants painted landscapes with color, and oceans teemed with reptiles and fish of astonishing variety. Yet the stage was set for one of the most transformative events in the history of life, the Cretaceous-Paleogene extinction event. Imagine a world suddenly altered. An asteroid, immense and unyielding, struck Earth with a force beyond comprehension. The impact unleashed catastrophic fires, tsunamis, and a cloud of dust and debris that blanketed the atmosphere. Sunlight was blocked for months, perhaps years. Photosynthesis faltered, food chains collapsed, and the vibrant ecosystems of the Cretaceous began to unravel. Life that had thrived for millions of years faced sudden, harsh reality. Dinosaurs, the dominant rulers of land, were among those most dramatically affected. Vast species, from gentle herbivores to ferocious predators, vanished from the planet. Their disappearance left a void in terrestrial ecosystems, a gap that would be filled by smaller, more adaptable creatures. In the oceans, similar devastation occurred, reshaping marine life and food webs. The world, once teeming with diversity, fell into silence.
Yet, even in catastrophe, life persisted. Small mammals, previously overshadowed by dinosaurs, survived in burrows, forests, and underground refuges. These survivors carried the genetic and adaptive legacy of millions of years, patiently enduring in the shadows. Their small size, flexibility, and varied diets became advantages in a world undergoing extreme transformation. Over millions of years, ecosystems recovered. Forests re-emerged, rivers flowed, and new forms of life began to diversify in the absence of the giants that once dominated. Mammals expanded into empty niches, evolving into forms that would eventually give rise to primates, carnivores, and herbivores of all sizes. Evolution accelerated, guided by the opportunities created by extinction and the persistent pressures of survival. The end of the Cretaceous reminds us of the dual nature of catastrophe. Destruction and creation are intertwined. Life's resilience is profound, its adaptability remarkable. From the ashes of dinosaur dominance emerged a new era, one in which mammals could flourish, explore, and ultimately shape the future of the planet. In reflecting on this moment, one senses the silent rhythm of Earth and evolution. Catastrophe was not the conclusion, but a transformation, a reset that allowed life to experiment, adapt, and diversify once again. The story of mammals begins here, in the shadows of giants, quietly preparing to inherit the world. And so, as the dust settled and sunlight returned, Earth entered a new chapter. The reign of dinosaurs had ended, and the age of mammals was quietly beginning. Life, ever resilient, continued its patient meditative journey across time, ready to explore new heights, diversify, and ultimately tell the next chapters of Earth's 13.8 billion year story. With the extinction of the dinosaurs, a new era dawned on Earth, the Paleogene period. The planet, scarred but resilient, became a canvas for life to experiment, diversify, and explore new possibilities. Mammals, once small and overshadowed, now began to expand into niches left vacant by the departed giants. This was a time of quiet evolution, patient adaptation, and the gradual rebuilding of ecosystems.
Imagine forests gradually thickening after the upheavals of the Cretaceous. Rivers carve new paths, mountains shaped climates, and plains spread across continents. Mammals of all forms, early primates, small carnivores, burrowing herbivores, explored these new landscapes. Each species carried adaptations fine-tuned over millennia, now allowing them to thrive in a world free from the dominance of dinosaurs. Plant life, too, flourished in new ways. Flowering plants spread extensively, creating complex forests and meadows. Insects, birds, and early mammals formed new relationships with these plants, driving pollination, seed dispersal, and ecological interactions. The web of life became intricate and interdependent, with every organism contributing to a slowly stabilizing world. Predation and competition guided evolution as always. Mammals diversified rapidly, experimenting with body size, diet, and behavior. Arboreal species explored the trees, terrestrial species grazed and hunted, and aquatic species adapted to rivers, lakes, and coastal environments. This experimentation set the stage for the rich mammalian diversity that would dominate Earth in the coming epochs. Climate played a crucial role. The Paleogene was warmer than today, with no permanent ice caps at the poles. Seasons shifted gradually. Rainfall patterns changed, and landscapes transformed, creating new ecological pressures. Mammals adapted, moving, foraging, and evolving in response to these challenges. The planet was alive with subtle, patient change. The Paleogene reminds us that life's recovery is neither sudden nor chaotic. It is a measured, meditative process. Every small adaptation, every ecological interaction contributes to the unfolding of complexity. Mammals, in their quiet persistence, began to shape the planet as much as it shaped them, influencing vegetation, predation, and the flow of energy through ecosystems. And so, as the Paleogene progressed, Earth slowly regained balance. Forests and grasslands expanded, rivers nurtured life, and mammals flourished. The world was both familiar and transformed, a place where life, having endured catastrophe, demonstrated its resilience and adaptability. The story of mammals, and eventually humanity, was beginning to write itself in the patient, enduring rhythm of evolution across deep time. Following the gradual recovery of the Paleogene, Earth entered the Neogene period, a time of increasing diversity, innovation, and complexity. Mammals, having survived previous upheavals, now dominated terrestrial ecosystems. Grasslands expanded across continents, forests diversified, and the planet's climate continued to shape the evolution of species. Picture vast plains stretching to the horizon, dotted with herds of grazing animals, early horses, antelopes, and large herbivores moving in silent rhythm across the land. Predators, both solitary and in packs, stalk these herds, honing strategies that would persist for millions of years. Evolution operated not in sudden bursts, but through patient, careful adjustment as species adapted to the challenges of a changing world. Mountains rose, rivers shifted, and continents slowly drifted toward their modern positions. These geological changes influenced climate, rainfall patterns, and the distribution of habitats. Animals responded. Some migrated, some adapted to new food sources, and others developed specialized behaviors for survival. Ecosystems became more layered and dynamic, each species influencing and responding to the other in an intricate web of life.
Plant life underwent a dramatic transformation as well. Grasslands spread widely, providing new food sources and shelter for herbivores. Trees and shrubs persisted in forests and river valleys, creating microhabitats and corridors for movement. Flowering plants continued to diversify, establishing complex relationships with insects, birds, and mammals. Pollination, seed dispersal, and ecological feedback loops intensified the interconnectedness of life. This period also saw the emergence of early primates and ancestors of modern carnivores. Arboreal mammals perfected climbing and foraging in forested regions, while ground-dwelling species adapted for speed, endurance, and social behavior. These adaptations laid the foundation for the ecosystems we recognize today. The subtle rhythms of life, feeding, reproduction, migration, and survival were all unfolding in harmony with the slowly changing environment. Climate fluctuations during the Neogene were moderate but persistent. Cooling trends began to set the stage for future ice ages, while regional shifts created deserts, savannas, and wetlands. Animals and plants responded with flexibility and innovation, gradually shaping the face of the modern world. Survival required observation, strategy, and collaboration within ecological networks. And so, by the close of the Neogene, Earth had entered a phase remarkably similar to the landscapes we know today. Mammals dominated the land, forests and grasslands thrived, and the rhythms of life were both familiar and dynamic. The patient, meditative unfolding of evolution continued, preparing the stage for the final chapters of this 13.8 billion years story, the rise of humans, the shaping of modern ecosystems, and the reflections of life across the living planet. As Earth transitioned from the Neogene into the Pleistocene, the planet entered an era defined by dramatic climatic oscillations. Ice sheets expanded across continents, glaciers carved valleys, and sea levels rose and fell with relentless cycles. These ice ages shaped landscapes, altered habitats, and imposed survival challenges that would profoundly influence life, including the rise of humans. Imagine vast expanses of tundra and steppe, interspersed with glacial rivers and lakes, where mammoths, saber-toothed cats, giant ground sloths, and early bison roamed. The rhythm of life was dictated by cold and warmth, by scarcity and abundance, forcing species to adapt, migrate, or perish. Predators and prey moved in a continuous dance of survival, each step carefully honed by the pressures of the environment. It was during this epoch that humans began to emerge as a distinct species. Early hominins, equipped with intelligence, dexterity, and social cooperation, navigated these shifting landscapes. Tools, fire, and communal hunting allowed humans to exploit resources in ways no other species could. Their evolution was gradual, measured, and intimately connected to the rhythms of the natural world. The Ice Ages sculpted Earth's geography and ecology. Glaciers ground mountains into valleys, created lakes, and redistributed soil and sediments across continents.
Forests retreated and advanced in cycles. Grasslands expanded and contracted, and new ecosystems emerged with every climatic shift. Life was in constant flux, adapting to frozen deserts, open plains, and thawing riverbanks. Human survival depended on observation, strategy, and adaptation. Clothing, shelters, and cooperative hunting enabled early humans to thrive where others might fail. They learned to read the landscape, predict seasonal changes, and navigate a world of scarcity and abundance. Their social structures, communication, and ingenuity allowed them to influence their environment in subtle yet profound ways, laying the foundations for civilization. Simultaneously, other species adapted in remarkable ways. Mammals developed thick fur, fat layers, and migratory behaviors. Birds adjusted nesting and feeding patterns. Life responded to the oscillating climate with flexibility, patience, and resilience. The Pleistocene was a testament to the enduring interplay between adaptation, environment, and survival.
And so, in the silence of frozen valleys and across the sweeping plains, life continued its meditative rhythm. Humans, emerging from ancestral lineages, joined the symphony of Earth, shaping and being shaped by the planet's forces. The Pleistocene was both a crucible and a classroom, teaching survival, adaptation, and the delicate balance of life on a planet in motion. With the retreat of the last great ice sheets, Earth entered the Holocene epoch, a period of relative climatic stability that continues into the present day. Forests, grasslands, wetlands, and deserts assumed their modern forms, providing habitats for countless species. Yet within this stable environment, a new force began to shape the planet in profound ways: humanity. Imagine early human communities spreading across continents, domesticating plants and animals, and gradually transforming landscapes. Agriculture allowed settlements to flourish, while trade, culture, and technology expanded the influence of humans far beyond their immediate surroundings. With each innovation, humans became not just participants in the natural world, but also architects of it. Ecosystems adapted to these changes. Forests were cleared for fields, rivers redirected for irrigation, and new species were introduced intentionally or accidentally into novel environments. Predation patterns shifted, herbivore populations adjusted, and even microorganisms responded to the altered habitats. Life everywhere began to feel the subtle yet pervasive touch of human activity. Yet nature's resilience persisted. Forests regrew when fields were abandoned. Rivers carved new paths, and species adapted to urban and rural landscapes alike. Evolution continued its patient work, favoring traits that allowed organisms to coexist or resist the changes brought by humans. Life's intricate web remained intact, though increasingly intertwined with human presence. Climate, too, continued to influence life. Seasonal variations, regional temperature fluctuations, and shifting rainfall patterns guided migrations, breeding cycles, and ecological interactions. Humans with foresight and technology began to anticipate and respond to these environmental rhythms, further entwining culture and biology in the unfolding story of the planet.
The Holocene is a period of reflection, resilience, and responsibility. Humans, now central players in ecosystems, hold the capacity to preserve, restore, or transform life on Earth. The meditative rhythm of evolution continues, but humanity's influence has accelerated the pace, bringing both challenges and opportunities. And so, in the forests, plains, rivers, and cities of the Holocene, life persists in a delicate balance. Humans, having emerged as a dominant species, are learning to coexist with the slow, patient processes of evolution that have shaped Earth for billions of years. The story of the planet continues, weaving together natural forces and human influence, a living testament to adaptation, resilience, and the enduring meditation of life across time.
As we arrive at the present, Earth is a tapestry of life, shaped by 13.8 billion years of cosmic and biological history. From the quiet, fiery birth of the universe in the Big Bang, through the formation of stars and galaxies, the rise and fall of continents, and the evolution of life from single cells to humans, the planet tells a story of resilience, adaptation, and the patient unfolding of complexity. Modern ecosystems are a symphony of interactions. Oceans, forests, deserts, and polar regions are home to countless species, each fulfilling a role in the delicate balance of life. Humans, with our intelligence, culture, and technology, have become central participants in this story, capable of both nurturing and challenging the systems that sustain us. Cities rise where forests once stood, agriculture reshapes land, and global networks of commerce, travel, and communication connect species and people in ways unimaginable just centuries ago. Yet the same forces that have shaped life for billions of years, adaptation, evolution, and environmental feedback, continue to guide the planet. Climate, natural selection, migration, and ecological interactions operate alongside human innovation, reminding us that the Earth is a complex system, meditative in its rhythms and resilient in its persistence. Every action we take reverberates across ecosystems, influencing species survival, landscape formation, and the continuity of life itself. Looking to the future, the story of Earth is unwritten. Humanity faces choices that can either harmonize with the slow, patient rhythms of the planet or disrupt them. Conservation, sustainable innovation, and a deep understanding of ecological interdependence offer the possibility of stewardship, allowing life to flourish alongside human development. The same evolutionary processes that have guided life from the simplest cells to intelligent beings continue to operate, patiently shaping what is to come. In quiet reflection, we see that Earth is both fragile and enduring. Catastrophes, extinctions, and environmental shifts have tested life time and again. Yet each time, life has persisted, diversified, and evolved in response. The narrative of the universe and of our planet is a meditative story of resilience, demonstrating that even after unimaginable trials, life adapts, thrives, and moves forward. And so, as we contemplate the present moment, we recognize ourselves as part of a vast continuum. Every species, every ecosystem, every star and planet is a note in the grand symphony of existence. The universe,
once born in silent fire, now hosts a planet where life reflects, observes, and shapes its surroundings. Earth's story continues, quiet, patient, and profoundly magnificent, inviting us to witness, learn, and participate in the ongoing meditation of the cosmos. This is the 13.8 billion-year story of the universe, told in silence, patience, and wonder. From the birth of atoms to the rise of humans, from cosmic fire to living forests, the narrative is complete, not in finality, but in continuity, as life flows onward, quietly, beautifully, and endlessly.